Welcome to this session on Fluvial landforms from Unit 4 of Principle of Geomorphology, TYBA Geography Semester 5. In this session, we will study how rivers erode and deposit material to create a range of distinct landforms. Before we begin, here are the references used for this presentation, along with a note that the diagram and photographs are used purely for educational purposes only. The word fluvial refers to the work of a river. A river acts as an agent of erosion, transportation, and deposition. Erosion is the removal of weathered material called the load. Transportation is carrying this material along the river's path, and deposition is the addition of this material to build new landforms. A river passes through three stages. In its upper or youth stage, the gradient is steep and velocity is high, so erosion dominates. In its middle or mature stage, the gradient is gentler, but the volume is higher, so the river carries a heavy load and transportation dominates. While in its lower or old stage, the gradient is almost flat and velocity drops. So in this stage, the deposition dominates. This diagram shows the three stages of a river from its youthful stage in the mountain to its old stage near the sea, and how the valley shape changes at each stage. We will now look at 7 erosional landforms produced by rivers: gorge and canyon, V-shaped valley, interlocking spurs, waterfall and plunge pools, potholes, meanders, and oxbow lakes, and the river terraces. This diagram recalls the processes of river erosion which you have already studied in previous chapter: hydraulic action, abrasion, attrition, and solution, which we will now see at work in specific landforms. Let's begin with the gorge and the canyon. Both are deep valleys, but a gorge has almost vertical cliff-like slopes of equal width at the top and bottom and forms in hard rock. A canyon has steeper slopes with a narrower base and a wider top, and forms in horizontally bedded sedimentary rocks. Both are shaped mainly by vertical cutting through the combined action of hydraulic action and abrasion. This diagram compares the cross sections of a gorge and a canyon, so you can see the difference in their shapes very clearly. This image gives a real-world view of a gorge, showing its steep, near vertical walls. Here is another example illustrating how a canyon looks in nature. Next is the V-shaped valley. When lateral erosion works along with vertical erosion in softer rocks, the valley develops slanting slides, giving it a V-shaped cross-section. This image shows a typical V-shaped valley with its characteristic slanting sides. Now interlocking spurs. As the river deepens its valley through vertical erosion, it twists and turns around obstacles of hard rock. Erosion is concentrated on the concave banks of each bend, so spurs on alternating sides of the river appear to interlock when viewed from above. On the opposite banks, there is a little erosion and a gentle slip-off slope forms instead. This diagram shows how interlocking spurs appear in the upper course of a river. Here is another visual showing the interlocking pattern of spurs along a widening valley. Landforms produced by river erosion continues, and next the waterfall and plunge pool. When the river flows from a hard rock onto a softer rock bed, the softer rock erodes faster, creating a steep drop over which water falls. Hydraulic action undercuts the base of the fall and abrasion deepens a basin at its foot called as the plunge pool. This diagram shows the formation of a waterfall and its plunge pool in the cross section. Notice the layering of hard rock and soft rock. Here is another illustration of the same process showing how waterfall gradually retreats over time. Now potholes. On an uneven river bed, water swirls in small depressions and pebbles trapped inside grind and drill circular holes into the rock. Potholes are formed purely by aberration. This image shows potholes formed on a rocky river bed. Notice how river water is swirled around in irregularities in the riverbed, creating vertical eddies. Then rocks get swept into the small depressions and abrade the hollow. These rocks are called as grinders because they actually grind the surface. The process then continues, deepening and enlarging the potholes. Here are two more examples of potholes showing their circular drilled appearance, and you can also see the pothole filled with the grinders. This is another close view of potholes on a river bed, and one can see a kind of polishing that has happened mainly because of aberration in a particular repeated mechanical movement of the grinders. And here is a further example showing potholes of different sizes occurring together. So here you can see that there are multiple potholes, and when the grinding continues, they actually merge into one another, leading to an extremely large size deep potholes. Next, meander and oxbow lakes. In the plain land of the lower course, the river develops loops and bends, which is called as meanders, with an inner loop on the inside of the bend and outer loop on the outside. When a meander loop is left behind and completely cut off from the river, it becomes an oxbow lake. Notice that here erosion and deposition both work together. Erosion at the outer bank and the neck, and deposition that seals off the lake. So meanders are a classic example of erosion landforms as well as deposition landforms. Now these diagrams show the process of how a meander evolves step by step and eventually gets cut off to form an oxbow lake. This image shows a completed oxbow lake lying beside its parent river, and you can also see another oxbow lake which is in the making. Here is another aerial view of an oxbow lake clearly separated from the main river channel, and if you observe closely you can see many other oxbow lakes parallel to the river, but many of them have developed just scars. There is no water left because they are the older oxbow lakes and many of them have already dried up, but the sediments which is deposited there can be very easily seen as a scar on the landscape. This slide summarizes all the erosional landforms we have covered along with their dominant processes. Gorge and canyon, is made by vertical erosion, V-shaped valley by vertical and lateral erosion, interlocking spurs by lateral erosion, waterfall and plunge pools are made by hydraulic action and abrasion, potholes by abrasion, meanders by erosion on the outer bank with deposition on the inner bank, oxbow lakes are made by erosion at the neck followed by deposition, and the river terraces are made by renewed vertical erosion during rejuvenation. Keep this slide handy for quick revision before your exam. Now we move to the depositional landforms. We will cover 5 landforms: alluvial fans, floodplains, natural levees, braided streams, and deltas. Let's start with alluvial fans. When a river leaves the hills and enters a flat plain, its velocity drops suddenly. Coarser material is dropped near the base of the hills, while finer material is carried further away, building a fan-shaped deposit at the foothills. This diagram shows the fan-shaped deposit typical of an alluvial fan. See how river suddenly changes the elevation. It comes from steeper gradient to the flat plain, and that is what leads to the making of such fans. Here is a real world image of an alluvial fan formed at the base of a mountain range. And you can see here that there are two fans which actually have merged with each other, leading to kind of a composite fans. This is another example showing the classic fan shape as seen from above. Returning briefly to river terraces, there are these are narrow flat surfaces on either side of the valley floor. They form when a river cuts a new narrower valley through an older flat valley that was filled with thick alluvium and gravel. Their presence tells us that the river has been eroding the landscape for a very long time. This image shows the stepped appearance of river terraces along a valley side. Observe the undercut bank, the point bar deposits, and also the meander scars and the oxbow lakes. Here is another view of river terraces showing flat surfaces at different levels. This is a further example of river terraces from a different valley. Observe the step-like structure. Now the floodplain. In the middle and lower course, the surface is almost flat. During floods, the river overflows its channel and spreads onto the surrounding land. Larger particles settle close to the bank, while finer particles are carried further away. As floods recede repeatedly, new layers of sediment are added every year, building up a thick floodplain over time. This diagram shows a river floodplain and how sediment spreads across it during a flood. So the first stage is before the flood, that is during the normal conditions, when the river water stays within its channel. However, when the flood comes or flood occurs as seen in the second stage, you can see that the larger sediments are deposited very close to the channel as the river loses its energy, while the smaller or finer sediments are carried away by the river across the banks and then deposited further away. And when the flood recedes, it creates levees or large natural embankments very close to the channel. Over the period of time, these deposited materials get compact, they are dried up, and finally becomes a very hard kind of a surface, which lead to embankment like structure along the river channel, as we said, referred to as levees. Here is another image showing a floodplain from above with its flat, fertile land. Next, natural levees, which we already have referred to in previous slide. These form during the same process of floodplain formation. The thickest and coarest sediments are deposited right at the river's edges. Since the river loses energy quickly there. As more sediments are added year after year, these edges get higher and more compact until the river actually flows between levees that stand above the general level of the floodplain. This diagram shows how natural levees build up along the sides of a river channel. This diagram is a bit similar to what we saw in the floodplain landform, but this particularly focuses the formation of the natural levees. Observe how the thicker and the coarser sediment gets deposited near the edges. Because they are relatively heavier and thicker, they cannot be uh, transported far away, and therefore they are quickly deposited along the river bank, while the finer sediments are carried further away. That makes the floodplains. Here is another cross section showing levees raised above the floodplain. You can observe uh, along the river bank the elevated kind of a portion or a raised part of the land, which is very running parallel to the river bank. These are called as levees. This image gives a real world view of natural levees along the river bank. Now, braided streams. When the river's velocity is reduced, it can no longer carry its coarser, heavier sediments and deposits them within its own channel. This process occurs especially when the river is in very lower course and usually runs over a flatter surface. This forms a central sandbar that diverts the flow of water, creating river islands and several separate channels, giving the streams its braided appearance. So river do not flow as a single channel of water, but it flows in multiple channels because of the obstruction created by the deposited sediments. This diagram shows the multiple interwoven channels typical of a braided stream. Here is an aerial image of a braided river showing its many separate channels around the sandbars. Next, the delta. When a river enters a standing water body, such as a sea or a lake, it loses its remaining energy and can no longer carry its heavy load. The main channel gets blocked by deposited sediment and divides into several distributaries, and continued deposition builds a triangular landmass at the mouth called a delta. This image shows the branching distributary channels of a river delta. Deltas can take different shapes. The arcuate delta is the most common type. It is composed of coarser sediments like gravel and sand and triangular in shape usually. Good examples are the deltas of the river Nile and the river Ganga. This is a satellite view of a major arcuate delta showing its fan-like triangular shape. This is delta of river Nile. Another type is the bird's foot delta. It is composed of very fine sediments like silt with very few distributaries that maintain clearly defined channels reaching far into the sea. The Mississippi River Delta is the classic example of it. This satellite image of Mississippi River Delta shows the finger-like bird's foot pattern of the Mississippi Delta. A third eye is the estuarine delta, which develops at the mouth of a submerged river and takes the shape of an estuary. Examples include the deltas of the river Elbe and the river Obe. This image shows an estuarine delta with its funnel-shaped mouth widening towards the sea. This summary slide lists all the depositional landforms with their dominant processes. Alluvial fans are made by deposition due to sudden loss of velocity as the river leaves the hills. Floodplains are made by deposition during overbank flooding along with lateral erosion that widens the valley. Natural levees are made by deposition of the coarest sediment first at the channel edges during floods, while braided streams are made by deposition of mid-channel bars when the load exceeds carrying capacity. Deltas are made by deposition where the river loses energy on entering standing water. Keep this slide handy for quick revision. That brings us to the end of this unit on fluvial landforms. Make sure you revise the erosional and depositional landforms along with their dominant processes, since this is exactly what you will be asked to explain in your 15-mark exam question. Thanks a lot for your patient hearing.